Okay. One quick thing. I noticed a similar problem in a few areas. If I have this, I can immediately write what? 10 squared equals that. I want you, that part you have to get down. You have to know how to go from log to exponential and from exponential back to logarithm. So what does that mean? That's the power that the base needs to become this. So write that. That's the power that the base needs. Now, could I solve that for x?
Yeah.
Hell yes, that's what you do when there's a variable inside of a logarithm. You're going to have to do this step eventually. Because look what happened to my variable. Is it still stuck somewhere? No, it's there. I can just add 7 and be done with it. Right? So rewriting from logarithmic form to exponential form is actually a step in solving. I'm doing the inverse of a log to get to the next step. All right, so that's going to come into play somewhere. On this first one, let's see, 65a, they ask you, what if t is 0? No time has gone by. So they want to know what's the score at 0 months. What is it? 82 minus 18 log 0 plus 1. Right? That scares me sometimes how I remember these things. What is log of 1? No matter what base, log any base of 1 is 0. And 0 times 18 is 0. Right? So then 82. There you go. So the average score after no time has gone by was an 82. Which is good. That's really good for an average. The problem comes in, and this is always something that worries me too, is retention. This is why you take math 90 4 years ago, and then you try to take 110, and your retention's going. So many guys are living that right now. So S of 6 months later, which just means plug a 6 in. This is why it's so important to understand what every variable represents. You would never put a 6 in place of the whole S, because that would mean how long until they have an average of 6? Well, you might have to wait 90 years, hopefully, or something crazy. Right? So then how do you do this? They add a little picture of a calculator next to it, because this part, I don't know what the hell log 7 is. So you got to plug it in the calculator, kind of approximate it. You get 82 minus, what's 18 times log 7? Or just put it all in at once, really is a better way to go. 66.79?
Round it out.
So 6 months later, the average grade dropped to just under 67. Scheisse. Yeah.
Wait, how did they get the 66?
Plug this into the calculator.
Oh, the whole thing.
Yeah, 82 minus... Because if you just plug this piece, you have to write down the decimals, and then if you approximate, you're screwing yourself. Just put the whole damn thing in. The calculator, eat that up. Just like that. All right, so part C... What was part C? How long until it's 54, is that right? So how long until the score, so replace S of t with 54. I want the score to be 54. And I'm solving for t, because I don't know how long it's going to be. I desperately want you guys... If the equation was... what would you do? If it was this, what would you do? Subtract 82, divide by negative 8. You would isolate the part that has your variable stuck in it. Math doesn't give a shit what your variable is stuck in. All right, the process just says, whatever your variable is stuck in, get that by itself first. Right? Okay, cool. So that's where my variable is stuck. So I'm going to get that piece by itself. So I'm going to subtract 82. By the way, if my constant cussing offends you, you'll be offended a lot. So subtract 82. I actually had somebody that was very offended with me. I said, I don't know what to do with you. You're going to have to change classes or something. 54 minus 82? Negative 28. It was negative 18. Is my thing with the variable in it alone yet? Nope. Divide by negative 18. And you get whatever the hell that is. Let's just say 14 over 9. I like it. Now, What's the base? So I can say 10 to that power equals this. That's how I let my t escape. It doesn't feel, I don't square both sides. I don't, and to tell you honestly, and I'm just going to show you this once. What we're really doing is we're raising 10 to both sides. That's the opposite of a logarithm, is 10 to a power, right? And then these would cancel. But the easier way to think about that is the base to that power is that. Because that's exactly what I get here. So t equals whatever the hell that is minus 1.
Oh, 14 times 14
No, it's 10 to the 14 over 9, right? That's what you would do. That's the base, and that's the power it needs to become the inside. That's what a logarithm means.
This is approximately 35 months.
About 35 months.
Yep. 35.
So just under 3 years later, they're down to 54 average. Damn. So can you imagine that? You make an 82 and you're Mac 90. 3 years later, you have retained the equivalent of making a 54 on that test. And then you're trying to get into 110. You can see why you might have some trouble doing that. That's why I'm trying to push for recency prerequisites on some math courses. I would say you must have taken this course sometime within the last 4 years or something. If not, you got to take the damn thing again. Right?
Yes, so whenever you're doing those, you just have to raise it to that power, to the base power.
Yes. Again, the basic idea of a log. The basic idea of a log is that the answer is the power. We said this before, but what does it mean, nuts and bolts? You know, the answer is a power, and it's what this guy needs to become this. It's one thing to say that, it's another thing to actually do it. So what power does 7 need to become x? So 7 to the third power would be x. That's what this says. So that is another way to write this. They are equivalent statements. They both say the same thing, just in two different ways. So now you can see how that's actually solving an equation. I have x equals whatever the hell that is. I'm done for that example. Yes, ma'am.
We're not giving the 35 months. We're not giving the word number.
Oh, all right. If you put into your calculator this, why is that not right? Because your calculator knows order operations, and this is where you get in trouble. This would do 10 to the 14th, and then it would divide that by 9. You want 10 to the 14 over 9. Calculator does not have eyeballs. It needs to know what things actually go together. Now, if you have a newer TI, you just don't come out of the exponent until you get the whole exponent up there. So, enjoy that, yes.
How come on here when you have 10 raised to the 14 over 9 equals t plus 1, t minus the 1?
Yes. Minus the 1, and then if you do that whole thing, you get this.
Oh.
Yeah.
I just
Oh,
plugged in the
because you
35
rounded
to
to
the T.
36.
Do what?
I plugged in the 35 to the T.
And where did the 35 come from?
I guess.
All right, you can just screw that to hell. There's no guess and check. If you guess and check, I don't care. You come and try to argue that with me. I'm not going to waste any time talking to you. You understand? Guess and check is not a valid way to do it. All right. So try it. I guarantee you, it's not a good way to go. All right. So that's the first one. Sure. So let's see. 63. Oh, let me see. Cool. So this is why I like doing review kind of stuff backwards, because we just did this. And this is the newest thing, so it's better to do it immediately so you don't forget what the hell you're doing. What's the very first thing I must do?
Put the log together.
Yeah, because if I had that, I could do what we just talked about here. I don't have that. I want to try to combine them so that I have a single logarithm, and then I can do what I have here. Right? So log base 4 of
Where
Careful. Subtraction. When you subtract powers, when you were dividing. If it was plus, then it would be x squared minus 15x. Yeah. Well, in which case I think, where's that helping you out? Well, it's not a plus and there's a minus, so it should be over. Equals 2. And now that we have a single logarithm,
You could take 4 to the
4 to the power 2.
yep, 16 equals
x over x equals minus 15.
11.
Minus 15.
15, thank you.
And you multiply minus 15.
Good. And this is not new. My variable's on the bottom. You multiply by that expression to get it out. You don't do anything weird. This is chapter 2 stuff, really. This is just solving this equation. Multiply x minus 15 up, you get 16x minus 240. So you get 15x equals 240. X equals 16. All right, because we just did that to get 240, so that's pretty much got to be the answer. Is it okay? Yeah, he's cool, and he becomes 1, that's fine. And let's check it. Log base 4 of 16 is 2. Log base 4 of 1, 2 minus 0 is 2, yay. Whoa. Okay. So you can check it like all. That was a nice one to check because it came on nice. All right. But you guys see the big point there. That's a different thing between logs and radicals. If I have 2 radicals, I can't really put them together. I don't have any properties to help me do that. Logarithms, yes, yay. So I don't care how many logs I got floating around. I just put them all in one big thing. I'm good to go. Square roots, I got to like square it twice and do all this weird shit in the middle, right? So logs have a little advantage there. 58. Oh, here we go. Yeah, you can do ln, you can do log, I don't care. Right, I'm a math guy, so I'm going to do ln. Now this is a number, you cannot divide by ln. Right? Doesn't make a damn bit of sense. It's like trying to divide by a square root symbol. Doesn't make any sense. So I divide by ln 4. Yeah, add 5, divide by 2. So that would be the answer if I want it exact. And then if you plug it in the calculator, you get
3.56.
3.5619.
so about 3562. Okay, cool. All right. Let's see. Real quick. 4 squared would be 16, right? So if this number was a little bit more than 2, it would make sense to make it a little bit more than 16. And if you plug that in, it's roughly 7, right? Twice 3.5 is 7 minus 5 is 2. So twice a little more than 3.5 is a little bit more than 2, which is why it comes out to a little bit more than 16. It works. You kind of with me?
Sure.
If not, it's fine. You just plug it in the damn calculator, right? I'm just trying to estimate, see if the answer makes sense. So what about 47? 47. I like that. 41. I'll do 41 in a minute. Dang it. And this is just, can you find your E button and use it correctly? So what do you get?
3753.
3753?
Yeah.
Okay, cool. Which makes sense. That would be 1 over E roughly. So it's 1 over almost 3. 1/3 is about 0.33. Makes sense.
We run like this.
Huh?
We run like this. And that's done.
That's done. Yeah, cool. There's no way in hell to do that really well by hand. More than I just did, estimation. 41 now. All right. So there are some problems like this in the homework, so I wanted to try to get some in here now. They tell you log A. What the hell's A? I don't know. Too bad. Log A7 is 5.09, blah, blah, blah. Log A of 2 1.83, blah, 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 blah. So, real quick, if I said, what's log A49? Well, what number is that related to? Yeah, that's log A7 squared. What can I do with that 2? So it's twice log A7. What's log A7? That number, it's twice that number done. So if you can relate it to what they're saying you know already, then you can just throw those numbers you know in. So the problem I gave you there, log A 3.5. How does that relate to 7 and 2? Yeah, 7 divided by 2. Now what property of logarithms can you use? Yeah, you're dividing the arguments, you have to subtract the powers. So this power minus that power. And so you just have to subtract 5 point blah blah minus 1.83 blah blah, because that's what those are, right? It just feels like you're cheating, but they already gave you a lot of information. And what's 5 point blah minus 1.8 blah?
Negative 3.29.
Should be negative.
Positive.
3 point whatever you just said. Okay. I like it. You just take, you rewrite the question they ask you in terms of the numbers you know something about. Use a property to bring those more directly in. Now I can just plug in the numbers I know. It's a lot less work than you might think there was to be involved there. And so number 38 is even a little bit more direct. 3 point whatever the hell it is. Let me put it up here. How do you get 14 out of those things? This is log base A of 7 times 2. So it's log base A of 7 plus log base A of 2. 5 point blah, 1.8 blah.
6.93.
6 point blah. Okay. I like it.
How'd you get the 3 over there?
Where am I at?
Bottom left.
Oh, okay. Let me do this more precisely. Log base A of 7 is what?
Your
5.0999.
Yeah.
okay.
What's log base A of 2?
1.8.
1.8301. And so you subtract those and you get 3 point whatever.
Oh, you just substitute.
Yeah. So it's a very strange looking question. I don't blame you for not knowing what the hell to do with that, but I just want to let you, I wasn't grading you, just trying to see what the hell they mean. That's all I mean. Rewrite what they ask you in terms of what you know, and then use properties to be able to use what you know. 33. So if you're bookless, you don't know what this one was. This is... Write it as a single logarithm. So you can see a bunch of properties just staring in your face. The first property you almost always use is the coefficients can become exponents, 11. So you can bring that 1/2 back up here. And then we can bring that 2 back there. Let me just stop right there for a second. So it's using that property in reverse. Right, that's why we take logs in an equation so the x can come back down. Here I want that number to go back up. Now here's really why I do that first. I know what log A minus log B is. I don't know what the hell 1/2 log A minus log. I don't know what that is. So I can get that 1/2 out of the way. That would kick so much ass. Of course I can. Bam, I just did. Now what's log of this minus log of that? Log of this
Divided.
over that, right? Subtracting powers happens when you are dividing stuff. If you just want to cut to the chase here, it's also minus that. So where's that going to end up?
Underneath.
Underneath. Because you're going to divide by that, right? If you want to see it happen, just go one step at a time here. So now it would be this over this divided by this. That's going to end up down here with the b. It's going to be divided by. basically anything that's positive will end up on the top, anything that's negative will end up on the bottom, because minus is divided by.
So if the 2 was positive, the last
If that was a plus, the c squared would have been on top. Why not? So if I had, real quick,
Why isn't it a to the 1/2 power over b all over?
it is a to the 1/2 over b all over c squared equals a to the 1/2 over b divided by c squared, which is times 1 over c squared. So if I take 7 and I divide it by 4, and I divide it by 2 also, that's actually 7 over 8. I've cut it in 8s. Cut it in 4s, cut those in halves, that's 7/8. That is a little something about math that students desperately just need to be able to do, bam. If you wanted to look at it all the way out, it's 7/4 divided by 2, which is 7/4 times 1/2, which is 7/8. Right? But if I cut 7 in 4s and cut them in halves, of course I cut it in 8s. Bam! Okay, sorry, don't mean to bam it. Now, real quick, since somebody asked, what if there was a plus there? Take this away. So, if there was a plus there, I would have gotten to this point here. Is this cool? I can just start here. Plus. You with me?
Yeah.
And then this would be log of a to the 1/2 over b times c squared over
1.
So we can just go on top. So you can skip that step and just go straight to the end and say all the positive stuff on top, all the negative stuff on the bottom. Right? Cool. Okay. I think we're getting more and more used to these properties of logarithms, and these are the ones that use them directly. But you can see solving equations, we have to know them also. To know how to rewrite it as a single logarithm. Cool. So any other what-if questions or things that still don't quite make sense yet? You're all like, well, that would take some time.
Or are we done?
Huh?
Are we done?
Nothing snaps attention like that. Are we leaving? Okay. So looking back, let me see. Oop, no, looking forward. Yeah, we're almost done. I just want to say a little bit about the next section, because tomorrow we get that quiz and stuff. You guys alright?
No.
Because you still have the whole chapter.
Yeah. Tomorrow, everyone wants to leave right now, and then that means we have to go through the entire chapter 15 tomorrow before the quiz.
That's long-term vision. Right now, what do I want? I want to be out of here, right, as a student. Before we get to this next step, let me give you a couple little things real quick. Because the most important thing about really math is you got the graphs, you got to understand the properties. But one of the most important things about mathematics is being able to solve equations. So let me give you something we haven't really seen yet, but you should be able to do anyway. Alright, try to do that one. So we haven't seen this yet, right? But they exist. They're out there.
As in on the quiz out there?
The quiz is only going to go through how? Through what? 14.4. It's only going to go... I'm going to make a special one for Terrence that goes through 15.1. 14.4. Yeah, 14.1 up through 14.4. That's tomorrow. So this is from section 14.6.
So ln.
So will this be on the quiz tomorrow?
No.
All right.
So first thing multiply by ln.
Don't say that. Don't ever say it like that, because you take the log of both sides. So I would never say, to solve this, I'm going to multiply both sides by a square root. Right? That just sounds weird. If you would, don't. take the square root of both sides. Take the log of both sides, right? Or the ln.
Yeah.
Keep going. So don't say anything else out loud. Try to finish that one out. We're not doing that together.
I thought you were going to do that with us.
No! Screw that, man. Come over here and take a break. So this problem involves very careful bookkeeping. It's not as easy as the other ones because you have, well, let's see why. So do what, both sides? Yeah, if you took a log, it doesn't matter. It's the same thing. Because the really weird thing, real quick, the really weird thing about logs, if I take ln of 7 over ln of 2, that's the same as log 7 over log 2. That's the same as log base 110 of 7 over log base 110 of 2. The ratio of logs is independent of the base. It's really neat. And that's why you're allowed to pick whatever log you want, because when you eventually make a ratio, it's the same. I don't care which log you pick. If you don't understand what the hell I just said, you pick whatever log you want to. So once I do that, why did I do that? Yeah, so that can come down. That can come down. You could. Slightly easier. You can't. Because it would be times. You'd have to divide it to the other side, in which case you get your variable on the bottom. So good. You can't get around that. You just can't. So just don't forget, ln 7 is a number. A number like 2. It's just an ugly number. So you'd have 2 ln 7. Let me put the x. Plus ln 7. How are we doing so far? Here, take a second. How do you solve that? How would you solve it? Distribute. Really? Yeah, you're right. Distribute. Because then you can get your x's together, right? And all that kind of stuff. So I'm not doing anything different. ln7 is a number. I can't solve this until I distribute so I can get my x stuff free so they can move. Right now they're stuck. They can't go anywhere. Same damn reason you said distribute there is the same reason why I'm doing it here. So ln7 times 2x is 2 ln7x. ln7 times 1 is ln7. Equals?
3.
And you can write it as 3x ln 29, doesn't really matter, but minus twice ln 29.
Do math.
Why does
Wait.
why does X come after 29 versus
Again, it doesn't matter. You can write this as 2x ln, so we just write it like this. Not sure why I'm writing it the other way anyway. Why does it not matter? Because this is all multiplication. I don't care what order I multiply in. So I was just trying to make that number look like a coefficient, but it doesn't really matter. If that's easier to follow, that's cool. Now you just got to remember, how do you solve for x? You get all your x stuff on one side and all your not x stuff on the other side, right? So I need this to come with this guy, and I need that guy to get the hell out of there. So I would subtract. You guys are really fun. Real quick, if I had 2x plus 7 equals 3x minus 29, what's your next step?
Subtract 7.
Yeah, you can subtract 7, or you can subtract 3x, or you try to get your x stuff together on one side and your number stuff together on the other side. Math doesn't care what else in there. It says you do the same thing. Here's my x stuff, and here's another x stuff. I need them together. So I'm going to subtract that x stuff over here. I need that out of the way. It's not x stuff. I need that on the other side. So I'm going to subtract. You know, they could have went the other way so I don't get so many negatives, but I don't care. All my x stuff is together now. All my number stuff is together over there. How the hell are these like terms?
Yeah.
Why are they not like terms? This is 2 x ln 7s, and this is 3 x ln 29s. I can't put those aren't like terms, right?
So that's it.
No. How do you solve for x? Are there 2 x's? No, there aren't. There's 1 x.
You gotta do that.
Factor out.
What math?
Factor.
Beautiful. Take an x out. Right. You've done this before. And if you haven't, then blame your teacher. Blame your bad memory, because you've done this before. You've had stuff where the variable was in more than one place. You get all of them on one side, and you take that variable out. It's a very standard thing to do. When my variable's in more than one place, get it all of them on one side and take it out. Because now what can I do to both sides?
Divide.
Divide by the stuff I don't want. Exactly. X times crap, I can divide crap on the other side.
How do you divide by crap?
Like this, I'm writing it up here for you. Somebody says, what'd you learn today? And you say,
I learned how to divide crap.
exactly. Divided by crap. Yes, ma'am.
So would it be bad to figure out what 2 ln 7 is? Get your decimal for that.
That would be so disgusting. I don't know if you guys understand. To try to carry some big decimal around here throughout this work, it actually is easier. But even beyond just easier, it's more correct to not do that till the very end. Because otherwise, when you're combining stuff and dividing stuff, you're approximating approximations, and it gets way off from what it's supposed to be.
So then you plug that in the calculator.
And you plug that in the calculator, yeah. So negative ln of 7 minus twice ln 29 over 2 ln 7 minus 3 ln 29. You got to put a bunch of parentheses in your poor little. Let me put it up here.
That was a 3 ln 29.
Huh?
You said 3 ln 29.
On the bottoms, yeah.
And it's definitely not one of them.
Are we really doing all of chapter 15 before the final?
We'll see what tomorrow's like.
Oh,
I will guarantee you this. Wednesday is going to be nothing but review.
Okay.
Wednesday we will have nothing new. So tomorrow is the last day for
New stuff.
new stuff.
2, 2, 8, 8.
All right, let me see. Negative ln 7
7.
minus, was it 2 ln 29? And that's the top, divided by parentheses for the bottom,
okay.
2 ln 7 minus, what is that, 3 ln 29?
Yeah.
Yeah.
God, who wrote that? Oh, yes, me. Hi. So I get that. So watch this. Watch this. Watch this. Watch this. You ready? See that little button right there?
Yes.
Stow in X. Now watch what I could do. 7 to the 2x plus 1. Now if you don't have the newer,
How'd you do that? 2 in the house.
if you don't have the newer one, you have to do to the in parentheses 2x plus 1. You with me? But I put x is x is the answer. So there's the one side. 7 to the twice x plus 1. Now do the other side. 29 to the 3x minus 2. I don't really need to put parentheses around there, but I'm so used to doing it. Look, there you go. I proved it. One side does indeed equal the other side. So that's a quick way to use your calculator to check answers. Is you store the answer in X, and then you can write the equations exactly as they look. Just put an X in there. It's kind of weird. Okay.
So that's what x always equals now in my calculator.
Say again.
Is that what x equals always in my
Now
calculator?
X is going to be that, except when you go to graph. Don't worry, graph is a separate thing. It doesn't have X having specific values.
How'd you do that still?
But on the home screen, X will always be that unless you change it again.
How do you change it back?
Change it back to what?
Whatever. Just
You put another number in, hit store. Yeah.
Can you scroll back up for me?
That's pretty cool.
Not really.
How did you spell it?
Right there. So here's the work I did. And then I got that number there, right? And then I did store. Stow. X. You can actually store in any, see these green letters? I don't know, in yours, yeah, they're green on yours.
yeah.
You can store them in any of those too. You can say store alpha n. So now it's in n if you want. Right, you got all those memory locations. It's crazy. Yeah.
So each letter has been stored before if your calculator gives it a number.
Yeah. So if you hit alpha B and a number comes up, somebody stored a number in B. Because otherwise it should just come up as 0. That's the standard.
And the other thing is you can go to second.
Does it make sense? Okay.
It's second.
So let me, one little preview. One little preview for tomorrow. We'll get out of here a little early. So pretend like that's a circle. And pretend like the center is 0, 0. Now this is kind of cool. A circle, what's the definition of a circle? And if you really think about it, it's almost, it feels like you're trying to define the color red to somebody who's blind. But what's the definition of a circle?
Everything's the same distance from the middle.
Beautiful. It's the collection of points that are equidistant from a point in the center. So doesn't that make sense? That would be a circle. Start at the center and collect all the points at the same distance away from the middle. That distance, of course, being the radius. So if I go from here to here, what point is that? I don't know. Let's call it xy. And what distance do I want this to be? R. It's amazing. So what's the relationship between x, y, and r? What kind of triangle did I just make? So what's the relationship of x, y, and r?
X squared.
X squared. Okay, now this is sounding better. Crazy. So now real quick. X squared plus y squared equals 16. That is a circle centered at 0, 0 with radius 4, exactly. R squared is 16, so the radius is square root of 16, 4. This one is a circle of radius 7, centered
On negative
Positive 1.
1,
Negative 2.
-2. So 1, -2, and then you go 7 away from that in the 4 main directions, and there's your circle. Right? So if I went to 1, -2, there's my center, and it just goes 7 away from that in these directions and connect them, I got my circle. Kicks ass. So do you think they're going to be in this form to start with? What do you have to do to make something in that form? Complete the square. Oh, scheisse. That's the word of the day. Married. You learn how to say shit in all the different languages. So it's a good thing to do. All right.
So what are we learning?
The more you know.
So that's
All right, guys. See you tomorrow.
Okay, really quick. This is right here.
Are you going to post the next homework?